So let's summarize what we have learned about solving systems of equations. We have two methods so far that we can use. One is substitution and the other is elimination. And we're going to talk about when it might be most useful to use one over the other. If we have a system of equations in which one of the equations has a variable that's already solved for, it would be easiest to use substitution. If we have one equation that has one of the variables with a coefficient of 1, it also might be easiest to use substitution. For elimination, if both equations are already set up so that they're in standard form, which remember means that we have x and y on one side and our constant on the other, then it might be easiest to use elimination. And if none of the variables in either equation have a coefficient of 1, then it's definitely going to be easiest to use elimination instead of substitution. In this first example, we could use either substitution or elimination, but one reason we may want to use substitution is because we already have a variable with a coefficient of 1. So it's really easy for us to just move this 3y over to the other side to have x is equal to 3y plus 4, and then go ahead and plug that into our second equation. So for our second equation, we're still going to have the 2. We're going to replace the x. We're still going to have the minus 5y and equals 5. And then we're just going to replace that x with 3y plus 4. And then we can go ahead and start distributing. So 6y plus 8 minus 5y is equal to 5. When we simplify here, we get y plus 8 is equal to 5. So y is equal to negative 3. So now that we know y, we just need x. And remember, the nice thing about substitution is that we've already solved for x here. So if we plug in x is equal to 3 times y, which is negative 3, plus 4, we get x is equal to negative 9 plus 4. So x is equal to negative 5. There's our second variable. So our solution as an ordered pair is negative 5, comma, negative 3. This next example is a case where we would definitely want to use elimination. So if you look, we have no variables that have a coefficient of 1. So if we tried to use substitution, it means we would have to deal with a bunch of fractions, which we would rather avoid. So with elimination, remember, we want to make either our x's or y's the same. I'm going to make the y's the same because I already have one positive and one negative. So I'm going to make both of my y's into 6. So that means I'm going to multiply this top equation by 2. And I'm going to rewrite it over here, so that's going to give me 8x minus 6y is equal to negative 6. And then I'm going to multiply the bottom equation by 3. And again, I'm going to rewrite it over here, so 15x plus 6y is equal to 75. Now I can go ahead and I can add those two equations together, so you'll notice my negative 6y and my positive 6y will cancel each other out. So we have 23x is equal to 69. We'll go ahead and divide both sides by 23. And we get that x is equal to 3. So now we can plug it into either equation to get y. I'm going to use the very top equation right here because it has smaller numbers. So 4 times x, which is 3, minus 3y is equal to negative 3. 12 minus 3y is equal to negative 3. So when I move the 12 over, negative 3y is equal to negative 15. Divide both sides by negative 3 and we get y is equal to 5. So as an ordered pair, my solution is 3, 5. As a reminder, we have 3 possibilities for solutions when we're solving systems of equations. The first option is that the system has one solution, and we write that as an ordered pair, x, y. The second option is that the system has no solution, and so remember, when that happens, we get something that's false, like negative 3 is equal to 2, so we have no variables left, and we get a statement that's false, and so we know that it has no solution. And the last option is that the system has infinitely many solutions, and that's also when we have no variables left, but this time we get something that's true, like 2 is equal to 2, so that's how we know it has infinitely many solutions. So this is going to be an example that either has no solution or infinitely many solutions. So I'm going to use substitution because you can see that one of my variables is already solved for. So this means I can go to my second equation and I can replace just the y with 2x plus 1. So I'll still have the 6x, I'll still have the minus 3, I'm just replacing the y, and I'll still have the equals negative 3. So in place of y, I'm going to put in that 2x plus 1. Next, I'm going to distribute the negative 3 to everything inside the parentheses. So I have 6x minus 6x minus 3 is equal to negative 3. So my x's are going to cancel out. I have no variables left, and I have negative 3 is equal to negative 3. This is true. So this means that this system has infinitely many solutions, and that is my answer. I don't write anything else for my answer except infinitely many solutions. For this last example, this is another one of those cases where I could either use substitution or elimination. Both of my equations are already in standard form, which means it might be easier to use elimination. I do have a coefficient of 1 on this top y here, so I could also use substitution if I wanted to. I'm going to just show you guys elimination again this time. And so you can see that I don't have my x's or my y's the same. I'm going to make the y's the same because that means I only have to multiply this top equation. I want to make this top y positive 2y though, so I'm going to multiply everything by negative 2. Because remember, I need one positive and one negative. So I'm going to rewrite those over here. Negative 4x plus 2y is equal to 2. And then my bottom equation won't change. It will stay 4x minus 2y is equal to negative 6. I'm going to go ahead and I'm going to add those two equations together. Now, when I do, I know my y's are going to cancel, but my x's cancel also. So remember, when everything cancels, it leaves 0 because there's nothing left on this side. Over on the other side, 2 plus negative 6 is negative 4. This is false. 0 does not equal negative 4. So this system has no solution. And again, this is all I write for my answer, that this system has no solution.